Hello, ladies and gentlemen. Root Beer here, looking at question 21, our very first question in Part C of our Grade 9 Pascal contest. The integer 636,405 may be written as the product of three two-digit positive integers. The sum of these three integers is. Okay, well, it might be a good idea to factor 636,405 into its prime factors, the smallest sort of building blocks of factorization, and then see how we can combine them to make some positive integers. Three two-digit positive integers. Okay, and then we'll take their sum. So 636,405. I want to find the factors. Now, we can mess around with our calculator just to speed things up, but well, where can I start looking for prime factors? Well, I notice it ends in a 5, so divide by 5 pretty quickly. And you can do it by hand, it's just a little slower. 127,281. Okay. So it doesn't end in 5, it doesn't end in an even number, so it's not a multiple of 2. Maybe a multiple of 3. And we can just divide by 3 on our calculator to see if it'll work, but a real quick test, add up the numbers. 1 plus 2 plus 3 is 10. 2 and 8 is another 10, that's 20, plus 1 is 21. Since 21 is divisible by 3, the whole number is divisible by 3. Now I can actually work it out. Okay. So that's a nice little trick. It really only works for 3 and 9, but it's a useful trick. Let's do the same thing. 4 and 2 and 4 is 10. 2 and 7, that's 9. So no extra factors of 3, no extra factors of 5. How about 7? I'll just divide by 7. Oh, yeah, that works. 6061. There are rules to test if something's divisible by 7, but if you've got a calculator, and calculators are allowed on Pascal papers, absolutely just use them. Can I get another 7 out of this? No, I cannot. How about an 11? Yep, you divide by 11, and you'll get 551. Can't get another 11 because the two outer numbers don't add up to the middle number. So let's try 13. Nope, can't work with 13. How about 17? No. I'm just going up by primes because we're trying to find prime factors. And if you do 19, you'll get 29, and that's prime. So this number, 636,405, is a 3 times a 5 times a 7 times 11 times a 19 times 29. Now, I need this to be written as a product of 3 two-digit numbers. Well, we've already got 3 two-digit numbers, and then we've got these other numbers sort of left over. So what can we do? Well, there's 3 of the single digits, there's 3 of the other numbers. Maybe we could combine them. So, for example, 5 and 11 is 55. Okay? 3 and 19 is 57, but, well, then 7 and 29 is going to be a little too big. 7 and 29 is 203. So we could try something else. Now, if I'm going to use one of the single digits with 29, and it has to be no bigger than when I multiply, I can't get bigger than 100. We might try 29 and 5. No, that's 145. That's a little too big. But 29 and 3 is 87. So let's pair those two up. Okay, so 87. 5 and 19 is 95. And then 7 and 11, 77. So there we go. We've got 3 different two-digit numbers. And the question is asking, well, what's the sum? And we get 259. And so now let's go back and take a look. Is 259 one of the possible answers? Yeah, there it is. So we're going to bubble in A. Now we can move right along to question number 22. So thank you guys so much for watching. If you want to stay up to date with this Pascal paper as it comes out, or just want to stay up to date with any of the math contests, feel free to subscribe. If you're enjoying the paper so far, why not throw a like on the video? But until the next time, have a wonderful day.